Big Bang Theory is a prevailing model for explaining the development of the known universe. According to the Big Bang Theory, the universe was once an extremely hot and dense state, and then it suddenly began to expand rapidly. As the young universe expanded, it began to cool. This cooling would eventually lead to the conditions we see today. Downward expansion of the universe from the original point of the Big Bang continues today. Most scientific measurements have determined that the Big Bang took place approximately 13.7 billion years ago. This is now considered to be the age of the universe as we know it. In discussing the Big Bang Theory, the original state of the universe before the expansion is referred to as singularity. It is believed that this singularity was incredibly small, hot, and dense. The energy contained within singularity was enough to eventually become all the matter and energy we now see in the known universe. After the singularity began to expand, it also began to cool. Over thousands or even millions of years, the cooling effect would allow all the energy to be converted into various subatomic particles. Over even more time, these subatomic particles would combine to form atoms, which are the building block of all matter. The first elements that came into existence was hydrogen, along with small amounts of helium and lithium. Hydrogen spread all throughout the expanding universe, and over time the gravitational forces of densely packed clumps of hydrogen compacted into stars. It was the nuclear reaction within these stars that would eventually produce the rest of the elements in the universe. As the stars began to form, increasing gravitational forces caused them to cluster together in groups. These clusters of stars would over time become galaxies we know of today. The Big Bang Theory has received widespread acceptance throughout the scientific community. It is considered to be the most accurate and complete explanation for the full range of information that has been collected by astronomers and other researchers and the observable phenomena we see today. Since the Big Bang Theory was first proposed, more and more evidence has been discovered that has validated the model. Our understanding of the universe has, of course, grown and changed over the centuries. It has become clear that the lights that human beings saw in the sky were actually stars like our own sun. The steady-state model of the universe was first developed. As the name implies, it was believed for centuries that the universe was relatively static, with the observable stars, and later the galaxies, staying pretty much in the same place relative to other stars and galaxies. When the Big Bang Theory was first proposed, it was rejected by many scientists of the day. Within a few decades, it became widely accepted. Big Bang Theory has been tested in a number of ways, using data based on observable phenomena like the movement of the galaxies away from each other, and more advanced scientific measurements that test high-frequency radio waves, microwaves, and other invisible phenomena. Although the Big Bang Theory has become accepted by most scientists, there have been some theoretical objections raised about the validity of the theory. One phenomenon that has led to the objections is the overall flat shape of the universe. When the Big Bang Theory was first proposed, the available measurements of the day showed the universe is relatively flat. Those who objected to the Big Bang Theory asserted that if the Big Bang Theory was accurate, the universe should be generally spherical, with the galaxies moving outward from the center in all directions. This objection was eventually put to rest when advances in science demonstrated how the gravitational effects of the galaxies on each other could lead to the flat shape of the universe. Another objection to the Big Bang Theory arose when it was observed that the galaxies are the farthest away from the post-singularity are actually accelerating, rather than slowing down. Though this would seem to be in conflict with the Big Bang Theory, recent theories about dark matter and dark energy have been proposed that could explain this acceleration. The existence of dark energy, for example, could be contributing to the acceleration. Even if another explanation arises, nothing new has come along that would actually disprove the Big Bang Theory. While the Big Bang Theory seems to do a good job of explaining the universe as we know it today, it does not and cannot explain the existence of singularity itself, or what caused singularity to suddenly expand. The observable phenomenon only go back so far to the time after the singularity began to expand. How the singularity came to exist, or what the universe was like before the Big Bang, are completely unknown.